Imagine a machine, not of gears and steam, but of shimmering gold and the most delicate, sensitive electronics ever built by human hands. Instead of pistons and cogs, it uses mirrors coated in gold, and instruments so precise they can detect the faintest whispers of light from the edge of the universe. This is the James Webb Space Telescope, or JWST, a marvel of modern engineering and the most ambitious space observatory ever launched. Floating 1,000,000 miles from Earth, far beyond the reach of our planet's shadow, it's our most powerful eye on the cosmos, peering deeper than any telescope before it. JWST doesn't just look out into space, it looks back in time, unlocking secrets that have been hidden for billions of years. The universe is so vast that even light, the fastest thing we know, takes ages to cross it. Every distant object we see is a glimpse into the past. When you look at the sun, you're actually seeing it as it was 8 minutes ago, because that's how long its light takes to reach us. JWST pushes this idea to the absolute limit, capturing the faintest, oldest light in the universe, light that has traveled for over 13 billion years. This ancient light comes from the very first stars and galaxies, born just a few 100 million years after the Big Bang. The further we look, the further back in time we see, each galaxy a snapshot from a different era of cosmic history. JWST is like an archaeologist's shovel, but instead of digging through layers of Earth, it digs through layers of time, uncovering the universe's earliest secrets. Its giant mirror collects ancient photons, tiny messengers that have journeyed across unimaginable distances, carrying stories from the dawn of everything. For all of human history, we've looked up and wondered where it all began, searching the skies for answers to our deepest questions. Now, for the first time, we have a tool that can actually show us the universe's earliest moments, turning our curiosity into discovery. JWST is the culmination of our species' relentless curiosity and our drive to explore the unknown. With this telescope, we're not just stargazers anymore, we're explorers, scientists, and dreamers, reaching across time itself. We're time travelers, witnessing the universe's earliest moments unfold before our eyes, seeing creation as it happened. Each photon it captures is a clue to our origins, a piece of the puzzle that helps us understand how everything began. The universe's story is our story, woven together across time and space, connecting us to the cosmos. And with JWST, we're finally reading the first chapter of that story, opening a new era of cosmic discovery for all of humanity. JWST is a masterpiece of global collaboration. Thousands of scientists and engineers from the US, Europe, and Canada joined forces. Its primary mirror, over 21 feet across, had to be folded like origami to fit inside a rocket. Once in space, it unfolded itself perfectly, 1,000,000 miles from help. To see the faint infrared glow of the early universe, JWST must be kept incredibly cold. A sunshield the size of a tennis court blocks heat from the sun, earth, and moon. This engineering marvel operates at -370 degrees Fahrenheit. There was no second chance. Every deployment had to work flawlessly. JWST stands as a monument to human ingenuity and our drive to reach for the stars. What is JWST searching for? First, it hunts for the first light, the earliest stars and galaxies after the Big Bang. Second, it studies how galaxies are born and grow, watching them assemble over billions of years. Third, it peers into stellar nurseries, seeing new stars and planets forming behind clouds of dust. Its infrared vision reveals what Hubble could not. Finally, JWST searches for other worlds, analyzing exoplanet atmospheres for signs of life. It looks for chemical fingerprints like water, methane, and oxygen. JWST may not find aliens, but it could find proof we're not alone. With every observation, it brings us closer to answering the biggest questions. The universe's baby pictures are finally coming into focus. In late 2024, beneath the clear, star-studded skies of Chile, a dedicated team of astronomers made a startling discovery. Their powerful telescopes picked up a faint moving smudge, an object that would soon be named Asteroid 2024 YR4. At first, it was just a barely perceptible blur against the vastness of space, but it quickly drew the attention of the scientific community. Early calculations suggested it could pass dangerously close to Earth, raising alarm among astronomers and planetary defense experts worldwide. An impact from an object this size would be catastrophic, with the potential to cause devastation on a global scale, worse than anything humanity has witnessed in modern times. But its orbit was uncertain. Humanity had just 8 months to find out if we were in danger. Every day that passed without answers increased the tension and urgency. Telescopes worldwide tracked the asteroid. But it was dark, distant, and incredibly hard to study. Even the most advanced ground-based observatories struggled to gather clear data. Its size, shape, and composition remained a mystery. Crucial details for predicting its path and understanding the threat it posed. Without this information, any prediction was filled with uncertainty. The International Asteroid Warning Network quickly coordinated a global response, connecting scientists and observatories across continents in a race to solve the mystery. They needed a better look, something only the James Webb Space Telescope, with its unmatched sensitivity and clarity, could provide. The call went out. Turn humanity's greatest eye toward the threat. Commands were sent, and the world's most advanced telescope prepared to focus on the mysterious visitor. The fate of the world could depend on what JWST saw. Every image, every data point, could make the difference between safety and disaster. It was a race against time, science versus uncertainty, as experts worked around the clock to unlock the asteroid's secrets. The world held its breath, united in hope and fear, waiting for answers from the edge of the solar system. JWST was about to become our planetary guardian, standing between humanity and the unknown dangers of the cosmos. Repointing JWST to a fast-moving asteroid was unprecedented. But this was a planetary emergency. Scientists and engineers rapidly retasked the telescope. JWST locked onto the faint heat of 2024 YR4, using its powerful infrared instruments. It didn't just take a picture, it analyzed the asteroid's composition and size. Webb detected the Yarkovsky effect, a tiny force that can alter an asteroid's orbit. This data was the missing piece. With Webb's precise measurements, scientists could model the asteroid's path with new accuracy. The cone of uncertainty shrank. The world waited for the final answer. JWST had given us the information we needed. The result was clear. Asteroid 2024 YR4 would miss Earth by 2 million miles, a distance so vast that our planet was never truly in danger. Yet the world had watched and waited, holding its breath as scientists tracked the asteroid's path with unwavering focus. Relief swept across the globe, uniting people from every corner in a shared moment of gratitude and awe. For a brief time, humanity was reminded of its common bond beneath the same sky. Science, collaboration, and technology had triumphed. Teams of experts working across continents and time zones had turned uncertainty into reassurance. The event became a powerful example of planetary defense in action, showing what's possible when nations and agencies work together for the safety of all. Humanity had passed a cosmic fire drill, proving our ability to respond to threats from beyond our world. JWST returned to its primary mission, peering deep into the universe's past, but its brief role as planetary defender added a new chapter to its legacy. It's not just a time machine, it's a shield, a sentinel watching over us as we journey through the cosmos. The cosmos is vast and beautiful but also unpredictable, filled with wonders and mysteries and occasional dangers. With tools like JWST, we're no longer helpless spectators, we are active participants shaping our own destiny among the stars. We are explorers, guardians, and storytellers, driven by curiosity and a sense of responsibility for our fragile world. Each discovery writes a new chapter in our shared cosmic story, connecting us to the universe and to each other. The journey has just begun, and the adventure ahead is limited only by our imagination and determination. And with every new image, we see a little more of who we are and where we're going together into the unknown.